The next is to learn how to calculate the formula mass and molecular mass. So, formula mass of a substance is the sum of the atomic masses of the atoms in the chemical formula of the substance. So, when we say formula mass, we are referring to non-molecular compound like sodium chloride. You know, this is a compound, and there is another compound. Let me use glucose C6H12O6. This is a non-molecular compound, but this one is a molecular compound. So, for non-molecular compound, we use formula mass to represent it. For a molecular compound, we use molecular mass to represent it, but both of them mean the same, just to differentiate between a non-molecular compound from a molecular compound. So that is why we call one formula mass and the other one molecular mass. And whether it is formula mass or a molecular mass, the unit is atomic mass unit. So let's go ahead and see how we do the calculation. This is also, you must have done this in your secondary school time as well, most of you. So we just want to calculate the molecular masses of all the formulas. So I will calculate for two of them. So I will calculate for sulfuric acid and for calcium sulfate hemihydrate. And so for sulfuric acid, of course, we were given all the atomic masses of each element here. So we have 2 atoms of hydrogen, so it means 2 atoms of hydrogen. We multiply it, we add it to 1 atom of sulfur. I'm talking about sulfuric acid. So 1 sulfur atom plus how many atoms of oxygen? We have 4 oxygen atoms. So 4 oxygen atoms. So we just replace the symbol with the values, that is the atomic mass of each element. So we have 2 times 1 for hydrogen plus 1 times 32 for sulfur plus 4 times 16 for oxygen. So we have 2 plus 32 plus 16 times 4, that should be 64, right? Yeah, 64. So if we add 64 to 32 to 2, we are going to get 98. So our final answer, which is the formula mass for sulfuric acid, is 98 atomic mass unit. For calcium sulfate hemihydrate, the same way, calcium, we have 1 atom of calcium. So 1 atom of calcium, Ca, plus we have 1 sulfur atom, so 1 S, plus we have 4 oxygen atoms, so 4, 0. And then this dot that you see here is also plus 0.5 water. So that is water times 0.5. So I will write 0.5 here. Then I'll open a big bracket. For water, we have 2 hydrogen atoms. So it's going to be 2H plus, and then we have only 1 oxygen atom. So 1 O for oxygen atom. So I close the big bracket. So for calcium, calcium is 40. So 1 times 40 is 40. Sulfur is 32. 1 times 32 is 32. And then oxygen is 16. 16 times 4 is 64. And then plus, this is 0.5. So I will still put 0.5 here. And then we do for hydrogen. Hydrogen is 2 times 1, 2. And then oxygen is 16. 1 times 16 is 16. And then we keep on going. 40 plus 32 plus 64 plus 2 plus 16, that is 18. 18 times 0.5, that is 9. So, and then we can do the final calculation that way. That will be 145 atomic mass units. So that is how to calculate relative formula mass of a compound or relative molecular mass of a compound. So let's go ahead. So here you may want to know the difference between that is, how do we determine the mass of one atom or mass of one molecule in grams? Because if you see all our units so far is in atomic mass unit, but if we want to express the unit in grams, we want to convert from atomic mass unit to grams. So for example, we have for hydrogen atom, for one hydrogen atom, the atomic mass unit of one hydrogen atom is 1. For calcium, it is 40 atomic mass units. For sulfuric acid, it is 98 atomic mass units. For glucose, it is 180 atomic mass units. So if you want to get this one in grams, so you just multiply by Avogadro's number. Multiply each atomic mass unit by Avogadro's number, you will get that atomic mass, you get the value of that, the mass of that substance in grams. So here we, did I say multiply? Sorry, you will divide by the atomic mass, we have it here. Divide by the Avogadro's number, which is 6.02 times 10 to the power of 23. So for example, for hydrogen now, it's going to be 1 divided by 6.02 times 10 to the power of 23. That gives us 1.66. For calcium, it's going to be 40 divided by that value. For sulfuric acid, it's going to be 98 divided by Avogadro's number. So anything you get there, you have gotten the mass of the substance in grams rather than in atomic mass unit.